This is how to do a chi-square as a test of the independence of two variables. We have a little study here in which 217 people are being asked whether they ate any cheese before they went to bed last night and whether they had any nightmares or bad dreams during the night. So we've got the four combinations. So these numbers are the frequencies. This is, in other words, how many people, in this case, said they had cheese and experienced nightmares. 98. So we've got the four combinations. Now this is called a contingency table, and it contains the frequencies that fit into each of the categories that we have. Now in SPSS, the way in which we get that contingency table in is like this. Rather than have a 2 by 2 table, we have to put it into the rows. So we've got the four combinations: cheese and nightmares, cheese and no nightmares, no cheese and nightmares, and no cheese and no nightmares, with the frequencies for each beside it. So if I just go into variable view, you can see this has been set up in the values. If I go into cheese, you can see I've put in 1 is cheese, 2 is no cheese. And for nightmares, 1 is nightmares, 2 is no nightmares. Now the first thing that we have to do is go into data and go down to weight cases. We click on weight cases by, and then we put the frequency into the frequency variable box and click OK. Now, a way in which we do a chi-square for this type of data, we go into Analyze and Descriptive Statistics, and we go into crosstabs. Now, another name for a contingency table is a cross-tabulation. So what we have here, in the rows I'm going to put nightmares in the rows and cheese into the columns. Okay. Note that we're putting the column labels in. Frequency just stays out here. Click on Statistics and we select chi-square. Click Continue and click OK. Right, so this is the output. Crosstabs, cross-tabulations. Tells you there are 217 cases. This is the cross-tabulation. As you can see, it's the same as the table that we started with nightmares here and cheese here, with the right number of figures here, and the total 217 matches. These are the chi-square tests. What we're interested in here is the one Pearson chi-square. This is the value of chi-squared, which is 59.04. Degrees of freedom is 1, and this is the significance level. So the significance is less than 0.001. So we have a significant result. Now down here it checks that all of the expected frequencies in the cells are greater than 5, and it tells you that no cells have expected counts less than 5. One of the main assumptions of chi-square is that the expected frequencies, that is the numbers you would have expected to have seen just by chance, must all be bigger than 5. If it's less than 5, then the chi-square won't be valid. It says the minimum expected count is 39. In a 2 by 2 or 2 by 3 chi-square, you can sometimes save the day if you do have expected counts less than 5 in any of the cells. And basically you can use Fisher's exact test. So you would, if it tells you here that you have cells with expected counts less than 5, you use the significance level from Fisher's exact test instead of the one from Pearson chi-square. Now this was a test of the independence of cheese and nightmares to see whether they were indeed independent. Now if they had been independent, in other words, eating cheese has nothing whatsoever to do with whether or not you have nightmares, then you would expect the Pearson chi-square result to be non-significant. Because it is significant, it tells us that there is a relationship between eating cheese and having nightmares. And as we can look at the numbers here, the highest number is in this cell, so people who ate cheese had lots of nightmares, where people who didn't have cheese were more likely to have no nightmares. So we can see what the relationship is. Okay, so that's what this type of chi-square test is looking for. That's what it tells us. And that's all there is to it.